Okay, Math 99. Today we're continuing to factor. And we've been working with our factor form pattern of x squared plus bx plus c, expecting that if we see this pattern, we can factor it as a product of two binomials. And factoring as a product of two binomials, we have special product rules when we have a binomial times a binomial, which are on your blue cards. FOIL, when the terms are different. Square of a sum, when we have a sum squared. The first terms are the same, the last terms are the same. It's the binomial, the quantity squared. We have a square of a difference. A minus b, the quantity squared. First two terms are the same, last two terms are the same. And we have the product of a sum and a difference. We have a sum and a difference where the first two terms are the same and the last two terms are the same. So we already know about these special product rules for a binomial times a binomial. We're expecting now that we can factor this trinomial, a special pattern, x squared plus bx plus c, as the product of two binomials. So factoring is our heavy part of this course, I would say. So we'll just continue to practice factoring. So we're told to factor, and those are your directions. 10 minus 3x minus x squared. Well, that looks like we have an x squared term as our highest degree term, but it's not in our form pattern. So let's rearrange to form, to our formula, to our form pattern, where our leading term is opposite of x squared minus 3x plus 10. And now we see that we have the pattern x squared plus something times x plus a constant. So we expect we're going to be able to factor this as a product of two binomials. Now another tip or hint, when your leading term has a negative coefficient, we're going to factor that out. So I'm just going to take a negative 1 times and use the distributive law in reverse. A negative 1 times what would give you the negative x squared? Positive x squared. Remember, we're just changing, we're looking for the opposite of our polynomial. We're just changing the sign of each term. And distribute a negative 1 times what would give you a negative 3x? Positive 3x. And distribute a negative 1 times what would give you 10? Negative 10. So now I have my true pattern, x squared plus bx plus c. Where my leading term has a positive coefficient. So now I'm going to build my factor table. I'm looking for factor pairs of negative 10 whose sum is the coefficient of the middle term, which in this case is a positive 3. So looking at my factor pairs, I'd have a negative 1 times 10, 1 times a negative 10, 2 times a negative 5, a negative 2 times 5. Negative 2 times 5 is a negative 10. I can cross that off. And if I add a negative 2 plus 5, a negative 2 plus 5 is that pattern for the sum of the factor pairs to equal positive 3. So now I can write my factorization. remembering, and this is a common error, even I make this mistake, I factored out a greatest common factor. Don't forget to factor it all the way through. So we carry forward our greatest common factor. We're going to factor this as, I can take the first term, x times x is x squared, gives us that leading term, and now my factor pairs are -2 and a +5. And we check with FOIL. So -1 times x minus 2 times x plus 5. We're checking with FOIL because the first two terms are the same, but the last two terms are different. So I have a -1 times x with FOIL would be x squared. Outer terms would be a +5x. Inner terms is going to be -2x. And my last terms, -2 times 5 is a -10. So -1 times x squared. We expect we can collect those like terms in FOIL. I'll get 3x minus 10. And then distribute a -1 times each term. -1 changes the sign of each term. And I end up with a -x squared minus 3x plus 10. -x squared minus 3x plus 10. So an excellent example involves pretty much all the high-end examples, adding all the rearranged to form first. Recognize that you have a form pattern to factor. Factor out a leading negative coefficient. Apply the distributive property in reverse. Build your factor table with our little puzzle. Factor pairs of the constant whose sum is the coefficient of the middle term. And then, of course, check with your product rules for special case binomial times a binomial. So I can tell you that this chapter's test will be heavy on factoring. Now remember our form pattern, x squared plus something times x plus a constant. We expect we can factor it as a product of two binomials. So we're asked to factor w squared plus 6w plus 5. Looks like my form pattern. My highest degree term is x squared. I have something times x to the first degree, and I have a constant. So expect I can factor it as a product of two binomials. So let's build our factor table. We need factor pairs of the coefficient, which of the constant, which is a +5, whose factor pair sum is the coefficient of the middle term, in this case +6. So I have a 1 times 5 and a -1 times a -5, and 5 is prime, so those are my factors. Whose sum of factors is? Well, 1 plus 5 is 6. So I can factor this as w as my first term and +1 and +5. And check. W plus 1 times w plus 5. The first two terms are the same, but the last two terms are different, so I'll have to use FOIL. FOIL from my blue card tells you how to distribute. And we arrive with the first terms will be w squared. The outer terms is a +5w. Inner terms, w. My last term is 5. With FOIL, we expect we can collect the like middle term for w squared plus 6w plus 5. W squared plus 6w plus 5. You can circle your factorization. Factor. B squared plus 7b plus 10. Factor. Well, I recognize that my leading term's highest degree is 2. So I have my form pattern of x squared plus something times x plus a constant, which we expect we can factor as a product of two binomials. So let's build our factor table. We're looking for factor pairs of the constant. It's a positive 10. Whose factor pair's sum is the coefficient on the middle term. And that is positive 7. So 10, factor pairs of 10. 1 times 10, a negative 1 times a negative 10, 2 times 5, 2 times 5. Well, negative 2 times 5 also times negative 5, but here's my factor pair. 2 plus 5 is equal to a positive 7. So I can factor this as v plus 2 and v plus 5. Check. Binomial times a binomial. The first two terms are the same, but the last two are different, so I'll have to resort to FOIL. My first terms, v squared. My outer terms will be a plus 5v. Inner terms are plus 2v. And my last terms, 2 times 5 is positive 10. Collecting those like middle terms, v squared plus 10, plus 7v plus 10. V squared plus 7v plus 10, you can factor, circle your factored answer. It checks. Factor. We're factoring the trinomial of the form x squared plus something times x plus a constant. We expect we're going to factor it as the product of two binomials. I have a squared minus something times a plus a constant, so I expect I'm going to factor it as the product of two binomials. Let's build our factor table. I need factor pairs of the constant, which is a positive 21, whose sum is, remember we collect like middle sums with FOIL, so whose sum is, and in this case, remember the coefficient is a negative 10. The sign is tied up in the operation of subtraction, so if you need to change subtraction to addition and add the opposite to recognize it's a negative 10, be sure to do so. The coefficient of the middle term is a negative 10. Well, now we need factor pairs of positive 21. That'd be 1 times 21, a negative 1 times a negative 21. Looks like 3 times 7. A negative 3 times a negative 7. A negative 3 times a negative 7 would be a positive 21, but a negative 3 plus a negative 7 would be our negative 10. So here's our factor pair. We have a negative 3 and a negative 7. Then we can check a minus 3, the quantity, times a minus 7. First two terms are the same, but the last are different, so we'll have to resort to our FOIL for distribution. I'll get a squared. The outer terms are going to be a negative 7a. My inner terms are a negative 3a. And the last terms, a negative times a negative is going to be positive. 3 times 7 is 21. A squared, collecting like middle terms. A negative 7a plus a negative 3a is a negative 10a plus 21. A squared minus 10a plus 21. You can circle your factored answer. Factor. B squared minus 2b minus 63. Well, I want to recognize that my highest degree term is to the second degree. I get x squared plus something times x plus a constant. We expect to factor that as a product of two binomials. So we're going to expect to factor as a product of two binomials. We'll build our factor table. And we're looking for factor pairs of the constant, which is the negative 63. We're looking for factor pairs whose sum is the coefficient on the middle term, which is a negative 2. Kind of catches people yet? Sign control. Change subtraction to addition and add the opposite. So you know the sign of your term. Otherwise, the sign of your term is kind of tied up, wrapped up in the operation of subtraction. Factor pairs of negative 63 would be 1 times the negative 63, negative 1 times 63. But when I add those together, I'm quite a ways from negative 2. Let's see, 3 times 21. So a negative 3 times 21 and 3 times a negative 21, but I'm still not able to add to the value of negative 2. 7 times 9. Negative 7 times 9 be a positive 2. 7 times a negative 9 would be a negative 2 when I add my factors. So my factor pairs are negative 9 and a positive 7. B, positive 7 and a negative 9. So let's check. B plus 7 times B minus 9. First two terms are the same, but the last two are different, so I'll resort to FOIL as my method for the product of these two binomials. B times B is B squared. The outer term is going to be a negative 9B. My inner terms be a positive 7b. The outer term, 7 times a negative 9, negative 63. B squared. With FOIL, we expect we can collect the like middle terms. Negative 9b plus a positive 7b is negative 2b minus 63. B squared minus b, 2b minus 63. Checks, so you can circle your factored answer. Factor, which is what we're doing all hour today. We have a pattern. We have a form pattern that we're recognizing we can factor as a product of two binomials. So on that recognition, we go ahead and follow our process, arrange to form, factor out any greatest common factors, and then build your factor table to factor as a product of two binomials. So let's factor s squared plus 8s plus 7. Well, let's see. My highest degree term is squared, so that's x squared plus something times x plus the constant. I'm expecting to be able to factor that as a product of two binomials. So let's build our factor table. Factor pairs of the constant, which is a positive 7, whose sum of factor pairs is equal to the coefficient of the middle term, which is a positive 8. 7's prime. That's a negative 1 times a negative 7. That'd be positive 7. Or how about 1 times 7? 1 times 7 is 7. 1 plus 7 is 8. So there's your factor pairs. let's check with FOIL. Because the first two terms are the same, but the last two are different, so we'll have to rely on FOIL to expand. First two terms, we get s squared. The outer terms plus a 7s. Inner terms plus a positive s. And the last term is 1 times 7 would be 7. S squared plus, we expect to collect like middle terms, and I get 8s plus 7. 7 squared plus 8s plus 7 checks. So you can circle your factored answer. Factor. C squared plus 2/7 c plus 1 over 49. Well, this looks like my highest degree term is to the second degree, so my pattern is going to hold. X squared plus something times x plus a constant. We expect we can factor it as a product of two binomials. Let's build our factor table. We're looking for factor pairs of the constant, which is 1 over 49, whose sum is the coefficient of the middle term, which is a positive 2/7. Well, factor pairs of 1 over 49, I'm thinking 1 over 7 times 1 over 7. Or a negative 1 over 7 times a negative 1 over 7. 7 times 7 is 49. And then adding the factor pairs, 1/7 plus 1/7 would be 2/7. So there's your factor pair. C plus 1/7, C plus 1/7. Let's check. I have C plus 1/7, the quantity squared. So on my blue card, I have the square of a sum. A binomial, I'm adding and I'm squaring it. So I expand that as, from my blue card, square of a sum. Square the first term, plus we're going to collect two like middle terms, a times b, and square your last term. Squaring a number, it's always going to be positive. Squaring a number, it's always going to be positive, and we're adding two like positive middle terms, so your middle term is positive. A in this case happens to be C, and B's position in this case happens to be 1/7. So now I can fill that into my form pattern. A squared, well, A in this case is C, but I need to square it. Plus 2 times A in this case is C, times B in this case is 1/7. Plus B in this case is 1/7, but I need to square it. So expanding, I have C squared plus 2 times 1/7 would be 2/7 times C, plus 1/7 times 1/7 is 1 over 49. C squared plus 2/7 C plus 1 over checks. So you can circle your factored result. So a little review with fractions there in order to factor and summate. Factor. C squared minus 17C plus 70. Looks like my highest agreed term is to the second degree, so it matches my form pattern, x squared plus something times x to the first degree plus a constant. We're going to try to factor that as a product of two binomials. Let's build our factor table. We need factor pairs of the constant, it's a positive 70, whose sum is the coefficient on the middle term, which is it's a negative 17. That's a case where you want to be careful. You may need to change subtraction to addition and add the opposite so you do recognize it's a negative coefficient. It's a common mistake and your answer is incorrect. So factor pairs of 70, well, that'd be 1 times 70, but if I add those factors, I get 71, quite a ways from negative 70. Could have a negative 1 times a negative 70, same thing. 2 times 35. Positive 2 times a negative 35. Three, 4, 5. 5 times what is 70? 14. Negative 5 times 14. Either way, it's the sum is not quite negative 17. 7 and 10. 7 plus 10 would be a positive 17. A negative 17 times a negative 10, or negative 7 times a negative 10 would be a negative 17. So there's your factor pair. C minus 7 and C minus 10. And we check. C minus 7 times C minus 10. First two terms are the same, but the last two are different, so we'll use FOIL to expand. Get C squared. First terms, outer terms, a negative 10C. The inner terms are a negative 7C. And the last terms, a negative times a positive. The positive 7 times 10 is 70. Collect like middle terms. I have two negative middle terms. A negative C plus a negative 7 is going to be a negative 17C plus 70. C squared plus a negative 17 plus 70 checks. So you can circle your factored answer. Factor W squared minus 11W plus 30. Again, we need to recognize that we're following our pattern of x squared plus something times x plus a constant. So we're expecting that we're going to factor as a product of two binomials. Let's build our factor table. We're looking for factor pairs of the constant, which is positive 30, whose factor pairs sum is the coefficient on the middle term. And the coefficient on the middle term is negative 11. Make sure you catch that. You may have to change subtraction to addition and add the opposite so you capture the sign of the term. So now our factor pairs, I have 1 times 30 and a negative 1 times negative 30. Three times 10, negative 3 times a negative 10. 2 times 15, I guess. Two times a negative 15. It's not quite going to be the right factor pair either. Four doesn't go into 30. How about 5? 5 times 6. A negative 5 times a negative 6. Negative 5 plus a negative 6 is negative 11. So there's your factor pair. So check. I have a binomial times a binomial. The first two terms are the same, but the last two terms are not. So we'll use FOIL to expand. First terms are w squared. Outer terms are a negative 6w. The inner terms are a negative 5w. And the last terms, a negative 5 times a negative 6 would be a positive 30. Collect like terms. We're collecting two like negative middle terms for 11w plus 30. W squared minus 11w plus 30 checks, so we can circle our factored answer. Factor. W squared plus w plus 3. Looks like our x squared plus something times x plus a constant. So we expect we can factor it as a product of two binomials. Let's build our factor table. We need factor pairs of the constant. It's a positive 3, whose sum is the coefficient on the middle term. The coefficient on the middle term is not 0, 1. 1 times w. And it's positive. So factoring 3, I get 1 times 3, a negative 1 times a negative 3, and that's it. 3 is prime. 1 plus 3 is 4, and a negative 1 plus a negative 3 is a negative 4. So there is no combination. So this is an example of it's not factorable. At least with the information we have at this point. So at my math lab example, it might say factor the trinomial w squared plus w plus 3, and you enter your answer in the text box, and it says type n if the trinomial is not factorable. So they'll give you an option to type your binomial times a binomial as your answer, or type n if the trinomial happens to be a case that is not factorable. A hint when you are factoring trinomials as the product of two binomials, these special cases, likely you're going to see some prime numbers involved. Because with prime numbers, there is a very limited number of factor pairs. The number itself times 1, or you have your sign control, -1 times a -3. But prime factors are limited number of factor pairs as compared to here we had some trial and error as we built our factor table, just weren't coming upon that factor pair that matched this required sum. And sometimes that trial and error factor table even takes a little more trial and error. But with prime numbers, you can easily determine your factor pair combinations and determine if it's factorable or not. Factor. S squared minus 3s minus 28. Again, what you want to be able to recognize quickly is that we're factoring a trinomial. This is, we're adding and subtracting. We're going to write our equivalent answer as a product. And I see that my leading term is to the second degree, x squared minus something times x to the first degree plus my constant. And I'd expect I can factor it as a product of two binomials, although I recognize that there are some trinomials of this form pattern that are not factorable, like the previous example. So I'm going to build my factor table and try to find that factor pair whose constant is a negative 28, and the sum of the factor pairs is the coefficient on the middle term. The coefficient on the middle term is -3. Change subtraction to addition if you have to. Change subtraction to addition and add the opposite. Now you see the sign on the term itself. So factor pairs of -28 be 1 times -28, -1 times 28. But when I add those, I'm quite a ways from -3. 2 times, it's 14, isn't it? Or a -2 times +14. Adding, still quite a ways from -3. 3 doesn't go into 28. 4 does. 4 times 7, a -4 times 7. The sum would be a +3, so I have 4 times a -7. 4 times a -7 would be -28. 4 plus a -7 is -3. So there's your factor pair. So let's check. S plus 4 times the quantity S minus 4. Well, that's a binomial times a binomial. Are the first two terms the same? Yes. Are the last two terms the same? No. So I need to resort to FOIL, which is on my special binomial product form rules on my blue card. So I'm going to expand. First terms be S squared. Outer terms are going to be a -7s. Inner terms are going to be a 4s. My last terms, 4 times a -7 is -28. S squared. Collect your like middle terms. I have a -7s plus 4s. Be a -3s minus 28. S squared minus 3s minus 28 checks. So you can circle your factored result. Factor w cubed minus 3w squared minus 40w. Well, I have a trinomial, but my leading term is to the third degree. And my form pattern that I've been working with, the leading term is to the second degree. But as I recall from my blue card, whenever I'm trying to factor, I should always, always, always look for a common factor. It's kind of one of my first strategies. Always look for a greatest common factor. So do you see a common factor in these terms? W to the first degree. So I'm going to use the distributive property in reverse. W times what would give me W cubed? W squared. Pick up your sign. W times what would give you 3W squared? (3W). Pick up your sign. And W times what would give you 40W? 40. W times what would give you 40W? We're trying to match above. Yep. So I was able to find the greatest common factor. I used the distributive property in reverse, and I have a greatest common factor, W times W squared minus 3W minus 40, which I expect I can factor as W. Don't forget to carry along your greatest common factor. Carry along your greatest common factor. It's a common mistake not to carry along your greatest common factor. It's a common mistake that I make sometimes. So carry along your greatest common factor, because we know now we can factor this, expect to factor it as a product of two binomials. So we get focused on factoring the trinomial again and drop that greatest common factor. So now let's build our factor table. We need factor pairs of the constant, which is a negative 40, whose factor pairs have a sum of negative 3. So negative 40, that's 1 times a negative 40. That'll be a negative 39. I'm quite a ways from negative 3. Negative 1 times 40 would be negative, positive 39, still quite a ways out. 2. How about 2 times a negative 40? Or 2 times negative 20 would be a negative 40. A negative 2 times 20, still quite a ways out. 3 doesn't go into 40. 4 does. 4 times 10. A negative 4 times 10 would be negative 40. When I add, I get positive 6. 4 times a negative 10, negative 6. 5, 5, let's see, negative 5 times 8 would be negative 40, and negative 5 times 8, adding, get a positive 3. How about 5 times a negative 8? 5 times a negative 8 is negative 40. 5 plus a negative 8, negative 3. There's your factor pair. W plus 5 and a W minus 8. So let's check. First two terms are the same, last two terms are different, so we'll use FOIL to expand the binomial times the binomial. So I have my greatest common factor times W squared. The outer terms will be a negative 8W. The inner terms are plus 5W. And the last terms, 5 times a negative 8 would be a negative 40. W times W squared. Collecting like middle terms, a negative 8W plus a positive 5W is going to be a negative 3W minus 40. And now distribute W times W squared, W cubed, pick up your sign. W times 3W, 3W squared, pick up your sign, and W times 40 would be 40W. W cubed minus 3W squared minus 40, that's a 40W, checks, so you can circle your factored result. All right. Section 5.2, factoring. We are looking at testing it, I believe, open until 2 o'clock. And then I'll be posting all grades. All right, thank you very much.